For this problem, we are going to first change it to slope-intercept form. Then we're going to graph it right here. And we're going to verify if this is in the shaded region, or meaning it's a solution or not. So the first step is, let's rewrite this so it's a nice slope-intercept form. So I'm going to first rewrite it as 3x minus 2y. Just rewrite the whole thing. And I'm going to get y by itself. To get y by itself, we need to get rid of this 3x. That's a positive 3x, so we're going to subtract it over. So I'm going to subtract it on the other side of this inequality sign. If you want to put a line down, you can, like that. So I subtract it over to the other side of the inequality. That leaves me on the left side a negative 2y. Okay, I still have the greater than sign. And I have these two left. Can those combine? No, these two do not combine. So I can't make this like a 1x or something. They don't combine. So we're simply stuck with a negative 3x and a 4, a positive 4. So again, we move this x over. The y by itself, you don't flip the sign. And you have these two left over. So our next step is to get rid of that negative 2. The negative 2 is connected by a multiply. So to get rid of it, you're going to divide it off. So it's gone. I now have y. But I can't just divide off one side. I have to divide off both sides. So when I divide off both sides, I'm going to divide this side by negative 2, which means divide each piece by negative 2. So I divided both pieces, which is the whole side, by negative 2. And what I end up with is, well, does 3 over 2 reduce? No, but a negative divided by negative, that is a positive 3 over 2. X. Don't lose the x. Many of you will forget or lose the x. And what's 4 divided by negative 2? It's negative 2. Now, there is a question here. Does that stay a greater than? Did I divide by a negative? Because I divided by a negative, the inequality is going to flip around. So it is now a less than. So that right there is my new equation, which we are now going to graph that. To graph this right here on your graphing calculator, you have to remember you're going to begin at negative 2 and move 3 over 2, meaning my m, or slope, is 3 over 2, and my b, my y-intercept, is negative 2, which means I'm going to begin at negative 2 on your y-axis. So I'm going to begin right there at negative 2 on your y-axis. That's what the b stands for. What does the 3 over 2 stand for? It's your slope, your rise over run. It's your directions, your movement is what I call m, how you're moving. So from here, we are going to do a rise of 3 and an over of 2. So we're going to rise 3 and over to the right 2. So I'm going to have a dot right there. So I'm going to go 1, 2, 3 up, and then 1, 2 over. There's my dot. Could I get more dots following the trend? Could I go up 3, over 2? Does that look like it's in the same pattern? Could I even go down 3 and this way 2? Does that look like it's still in the same pattern? You can get as many dots as you want, but you really only need 2. 2's good. Okay, 2's good, but you can get more to make sure your line's good. Okay, so the thing is, with inequalities, you don't always make a solid line. Is a less than a solid line? No, it's a dotted or dashed line because it's a less than, not a less than or equal to. So what I'm going to do here is I'm going to make a dotted, aka a dashed line. And then I'm going to choose which side to shade. Because either this side has the answers or this side has the answers. The line right here is a boundary. It's not included in the answer because of the dashed. If it was or equal to, it would be solid, which means it's part of the answer. But how do we decide which side to shade? Well, you are going to, look, less than means below. So if this is a little slide, can you tell below the slide is down here? If it was greater than, it'd be on this side, the top of the slide. So what I'm going to do is I am going to shade this side down here. Let me put that line. Ooh, that's not what I wanted. Let me undo that. And I am going to put this line in red so you can see it better. See a dotted line? And you have that side shaded. In order to verify this, we can either verify this equation or this. I'd prefer verifying the original, because what if you mess this up, changing it? So we're going to verify this coordinate with the original function. So we are going to take the original function, but wherever the letters are, we're going to take them out, and we're going to plug something in for them. So for the x, because that was an x, we're going to plug the x value of this. And for y, we're going to plug the y value. So just as a reminder, hopefully you remember x, y. Those are the coordinates. So what is going to be here for x? Well, which of these two numbers is x? The -1. So we're going to stick -1 right there. And what are we going to stick right here for y is the 3. Now, if you did it on a calculator, you can crunch this with the calculator. I'm going to do it by hand. So 3 times -1 is -3. 2 times -3 is -6. Then, if you combine -3 and -6, you get -9. Is -9 greater than 4? Is that true or is it false? You should know that it is a false statement, so that is no, it is not true. I should see that on your test, that you have verified it. So that coordinate is not true. Now, what does that mean? Well, you could have easily checked this with the graph. There's what I mean. Could you go and find -1, 3 on your graph? -1, 3. Isn't that -1, 3 right there? That's -1, 3. Is that in the shaded region? Is it down here in the shaded region? No. So right off the bat, did we know that -1, 3 was going to be a no? Just because it wasn't in the shaded region? Oh. If this and this do not agree with each other, are one of them wrong? If you, say for instance, you plugged in a coordinate down here. Let's say we chose that one. Do you see that's 3, -1? If I plug in 3, -1, should it come out true? If I plug in 3, -1, it should come out true. If it didn't when you did this, either your graph or your plugging is wrong. Something is going wrong, so you need to go back and see where your mistake is. All right. So let's think about this. If I gave you the coordinate, for instance, -4, -3. Do you think that is by looking at the graph, is that true or false? Could you quickly look and find that dot? -4, -3. Is that true or false? Can you see it's false? So that would be a no, just by looking at it. But what if I had 4, 1? Over 4 up 1. Is that true? Yes, it is. So what I'm trying to point out to you is you could check by looking at the graph, and you need to check by plugging numbers in. For the test, I want you to see you plug the numbers in. I want to see that you know how to do that. But you can also make sure it looks graphically. It also is a good way to make sure your graph is right. There's not an error on it, possibly. Don't forget dotted or solid lines. Don't forget to shade top or bottom. Remember, this is the greater side, the top. This is the lesser, the bottom. Don't forget to change it before you graph it. It helps a lot to graphing it. Good luck.